Welcome to our journey through the cosmos, where we explore the largest stars in the universe. Let's dive into the world of supergiants and hypergiants, where we'll encounter some of the most extreme and awe-inspiring objects in the known universe. UY Scuti. It's the largest known star by radius. This red supergiant, located in the constellation Scutum, is so large that if we replaced our Sun with UY Scuti, its outer edges would extend beyond the orbit of Jupiter. Imagine looking up at the night sky and seeing UY Scuti dominating the view, a colossal glowing orb dwarfing everything else in sight. It's a humbling thought, isn't it? To think that something so vast exists out there in the universe. And yet, there it is, a testament to the incredible power and scale of the cosmos. If UY Scuti is the reigning champion of size, then VY Canis Majoris is a worthy contender, a true heavyweight in the world of hypergiants. This star is not just a mere giant, it's a behemoth that challenges our understanding of stellar dimensions. Located in the constellation Canis Major, this red hypergiant is a monster of a star, boasting a radius so large that it would engulf the orbit of Saturn if it were to take the Sun's place in our solar system. Imagine a star so vast that it could swallow our solar system's outer planets with ease. VY Canis. Majoris isn't just about size, it's also one of the most luminous stars known. Its brightness is so intense that it outshines thousands of other stars combined, making it a beacon in the night sky. But here's the thing about stars like VY Canis Majoris: they live fast and die young. These massive stars have a tumultuous existence, burning through their fuel at an astonishing rate. They burn through their nuclear fuel at an extraordinary rate, leading to relatively short lifespans. Unlike our Sun, which has a stable and long life, hypergiants like VY Canis Majoris are destined for a brief but brilliant existence. And when they do finally reach the end of their lives, they go out with a bang, exploding as spectacular supernovas that can briefly outshine entire galaxies. These explosions are not just endings, but also beginnings, seeding the universe with heavy elements. It's a reminder that even in the universe, even among the most colossal and powerful objects, everything is transient. The life cycle of a star like VY Canis Majoris is a testament to the ever-changing and dynamic nature of the cosmos, where even the mightiest stars have their moments of glory before fading away. Our next stop takes us beyond the Milky Way to the Large Magellanic Cloud, a satellite galaxy of our own. Here we find WOHG 64, a red supergiant shrouded in mystery. Its size rivals that of both UY Scuti and VY Canis Majoris. WOHG 64 is surrounded by a thick torus of gas and dust, a cosmic shroud that makes it difficult to observe directly. This shroud is thought to be material ejected from the star itself, a testament to the violent stellar winds that buffet these massive objects. As WOHG 64 sheds its outer layers, it's literally changing its shape and size, evolving before our very eyes. It's a reminder that the cosmos is a dynamic and ever-changing place. Chapter 4: Vega, a familiar face in the cosmic crowd. Now, let's take a break from the supergiants and hypergiants for a moment and turn our attention to a more familiar face in the cosmic crowd: Vega. This star has been a point of fascination for astronomers and stargazers alike for centuries. Vega, located in the constellation Lyra, is not nearly as large in radius as UY Scuti or VY Canis Majoris. However, its significance in the night sky cannot be overstated. In fact, it's only about twice the size of our own Sun. This makes it a medium-sized star, but its brightness and proximity to Earth make it stand out. But what Vega lacks in size, it more than makes up for in prominence. Its luminosity is about 40 times that of the Sun, making it one of the most luminous stars in our vicinity. Vega is one of the brightest stars in our night sky, easily visible to the naked eye. It has been used for navigation and has been a part of many cultural stories and myths. It's also surrounded by a debris disk, a ring of dust and gas that may be harboring planets. This disk is similar to the early solar system's protoplanetary disk, hinting at the possibility of planet formation around Vega. So while Vega may not be a giant in the same league as UY Scuti or VY Canis Majoris, it's a fascinating star in its own right. Its brightness, proximity, and potential for planet formation make it a key object of study in modern astronomy. Chapter 5: Mu Cephei, the Garnet Star. Back to the realm of supergiants we go, and this time we're headed to the constellation Cepheus, where we find Mu Cephei, more affectionately known as the Garnet Star. This star is a true standout, and not just because of its size, though it is a whopper, nearly as large as UY Scuti. What makes Mu Cephei so captivating is its color. It's a deep, rich red, like a glowing ember in the vast expanse of space. This crimson hue is a telltale sign of Mu Cephei's advanced age and evolutionary state. Mu Cephei is still an incredibly luminous star, shining with the brilliance of tens of thousands of suns. It's a reminder that even in their twilight years, stars can still be incredibly powerful and beautiful. Chapter 6. Betelgeuse, a star on the verge of a supernova. Let's talk about Betelgeuse, a star that needs no introduction. Located in the constellation Orion, Betelgeuse is one of the most recognizable stars in the night sky. It's a red supergiant nearing the end of its life, and when it goes, it's going to put on quite a show. We're talking about a supernova, an explosion of unimaginable power that will briefly outshine all the other stars in our galaxy. Predicting exactly when Betelgeuse will go supernova is tricky business. It could happen tomorrow, or it could happen thousands of years from now, but one thing's for sure. When it does go, it will be a spectacular sight. Chapter 7. Our next stop takes us to the constellation Scorpius, where we find Antares, a red supergiant that marks the heart of the Scorpion. Antares is one of the brightest stars in the night sky, a fiery beacon that has been used for navigation and storytelling for centuries. But Antares is more than just a pretty face. It's a massive star, much larger than our own sun, and it's nearing the end of its life. Astronomers estimate that Antares is only a few million years away from its explosive demise. When Antares does go supernova, it will be a sight to behold. Chapter 8. Hypergiants pushing the limits of stellar evolution. We've talked about supergiants, but now let's delve into the truly extreme realm of hypergiants. These are stars that push the very limits of stellar evolution, behemoths that dwarf even the largest supergiants. Hypergiants are incredibly rare, and for good reason. They require truly extraordinary conditions to form, conditions that are only found in the most extreme environments in the universe. Hypergiants are also incredibly short-lived, and when they do finally reach the end of their lives, they go out with a bang, exploding as supernovas that can briefly outshine entire galaxies. Chapter 9. S. Doradus, a variable hypergiant in a stellar nursery. In this chapter, we delve into the fascinating world of one of the most extraordinary stars known to humanity. Our quest for the most extreme stars in the universe takes us back to the large Magellanic Cloud, a satellite galaxy of the Milky Way. Here we find S. Doradus, a hypergiant that embodies both power and variability. This star is not just any hypergiant, it is a beacon of stellar extremes. S. Doradus is a member of a rare class of stars known as luminous blue variables, or LBVs. These stars are incredibly bright and massive, often exceeding the luminosity of our sun by millions of times. These stars are characterized by their dramatic shifts in brightness and spectral type, making them some of the most unpredictable objects in the cosmos. The changes in their brightness can be so extreme that they can be observed from millions of light years away. These variations are thought to be caused by instabilities in the star's outer layers, which are constantly expanding and contracting. This pulsation is a result of the intense internal processes that govern the life of such massive stars. S. Doradus is a reminder that even the most massive and luminous stars are not static objects. They are subject to forces and processes that can lead to significant changes over relatively short astronomical timescales. They are dynamic and ever-changing, and their evolution can be both dramatic and unpredictable. The study of stars like S. Doradus helps astronomers understand the life cycles of the most massive stars in the universe, shedding light on the complex mechanisms that drive their behavior. Chapter 10. KW Sagittarii, a massive red supergiant in the Milky Way's heart. Our final destination takes us back to our own galaxy, the Milky Way, where we find KW Sagittarii, a massive red supergiant that ranks among the largest known stars. KW Sagittarii is a true behemoth, with a radius estimated to be over 1,000 times that of our own sun. If it were placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. KW Sagittarii is also incredibly luminous, shining with the brilliance of hundreds of thousands of suns. It's a true standout in the Milky Way, a beacon of cosmic power that can be seen from vast distances. The universe is full of wonders, and we've only just begun to explore them. Outro Cosmic Perspectives. Thank you for joining me on this journey through the cosmos, where we explored the largest stars in the universe. Stay curious and keep looking up at the stars.
Like and subscribe to start your journey today.